experiment 4 for physics 1102 on voltage and current, and there'll be a part from the lab on EKG using references in the book on section 1712, or if you can find it online. We'll be using this breadboard we have indicated here, and we will be measuring voltage and current for different kind of circuits as we move into chapter 18 and 19 on current, voltage, and resistors. So what we're going to be using is this breadboard, and we'll be measuring voltage on the right side here, and we'll be measuring current on the left side. Now voltage, so we'll be using these probes. I'll zoom in for these when we get to those parts, but I'll go through the first parts that we're going to have here and do them each separate. So the first one we're going to be doing is a circuit, and I will end up setting this up. So we're going to have here, if you get your handout out, is if we have a series circuit, and a series circuit will be one where we go from one resistor and we use these R1, R2. An example of resistors are these little things here. All right, and our R3, R4. And we call this a series circuit because we go in one loop from one back to the circuit. So here's our battery, plus 15 to bind to ground, and we go back, and there are no what we call junctions when we do this. So what we're doing here is this one will be 1 kilo ohm. This one will be 2.2. This one will be 4.7. And this one will be 2.7 kilo ohms. All right, so we have a total of 15 volts. And to measure the voltage across each one will be given by this formula up here of RV sub N is R sub N over R1, R2, R3, R4 times the overall voltage. So I'll do one example here to get you started. For here, let's do R1. So that would be V1, would be R1. And since the resistors are all in, this is in kilo ohms, that's in kilo ohms, we can just not worry about that. So it'll be 1 over 1 plus 2.2 plus 4.7 plus 2.7 times 15. So the predicted should be, for this case, turn it on, will be 1 plus 2.2 plus 4.7 plus 2.7 is 0.094 times 15, so times 15 should be 1.41 volts. So that would be the result for the first one. Okay. And so for R2, we would put, instead of 1, we'd put 2.2. All the rest is the same. So this is what we're going to do. So what you're going to do then is predict this for each one. All right, and then I'm going to actually, I'll let you fill in that table, and then I'm going to actually do the lab in the next part. And so okay, now we have set up, I've set up the apparatus now. We have plus 15, ground plus 15, which then, based on these things, everything along this here is, so we have, this goes to the 1 kilo ohm, which then connects to the 2.2, which then connects to the 4.7, which then connects to the 2.7. So I'm going to do these in order, again, as we have from the lab handout. 1, 2, 3, 4, as shown in the lab handout, 1, 2, 3, 4. And you should have already filled out your data table, because they're not going to be necessarily exactly the same as what we're going to get. They should be fairly close, but they may not be exactly the same. So again, voltage is here. And so I'm going to measure the first voltage. And hook this up. And hook this one up. And we get, as you see, 1.42 volts. You should be able to read that pretty clearly with the lab. 1.42. All right. The next one we're going to do is, so that's R1. Next one we're going to do is the 2.2K. And the way we measure voltage is on either side of the resistor. We don't take anything apart. So what I'm going to do is hook this up to here and go across those two. And we see for the 2.2, we get 3.10 volts. 3.10 volts. All right? So again, we're just going across to do that. Measuring voltage is easy because you're just measuring the voltage across it. We don't have to take anything apart to do that. All right, now I'm going to go across the third one, and that's R3, the 4.7, and for that we get 6.58. 6.58 volts. Don't worry about the sign. We're only worrying about the sign of the number. That's the third one. And then the fourth one, we go across again. And this is then 3.85 volts. 3.85 volts for R4, which is the 2.7 kilo ohm. So again, we have a series circuit of 1, 2, 3, 4, and I measure the voltage across each one. So you can measure and predict and see how they compare to the actual values. So that's the first part. All right, we're now going to do the next part of the lab. And in this case, we're going to be looking at making this setup. And what we've set up is a 1 kilo ohm resistor to this, what we call this potentiometer, this slider, and we're measuring voltage here. And what we're going to do is do slider position. So I'm going to go slider position starting with 0, and then go up to 1, start with 1, and go to 2, 3, 4, 5, 6, 7, 8, 9, 10, and record the voltage for each one of those, and we'll draw it on a graph here. So what you're going to do is record 1, 2, 3, 4, and I'll give the voltage for each one of these. So if you want to make a table like this on the graph, that's fine. And then what we're going to do is you'll just graph position versus voltage for each one. So I'm going to use, again, this one on the right, which you should be able to read. So I'm going to go to position 1 or position 2. Okay. And that's 1.09 volts. 1.09 volts. All right, that's position 2. Then position 3. Okay, that's 2.63 volts for position 3. Then the next one's position 4. That's 4.42 volts for position 4. For position 5, that's 5.89 volts for position 5. Then position 6. That's 6.71 volts for position 7. Let's see here. For position 7, I get 8.37 volts. For position 8, I get 9.91 volts. For position 9, I get 11.47 volts. And for position 10, I get 13.25 volts. All right? So those are the numbers I have for each one of the graph. All right? So you're going to record these values, put them on the graph, and we're mostly looking at the shape of the graph for this result. And we'll be comparing it to the results we have. All right? So we plot voltage against resistance. That should be able to give us a current. Okay, for the third part, we're going to be looking at current in a parallel circuit. And we're going to be using this setup here. And the way this works is we'll be using 5 volts. And we'll be going around to 1K, and then we will split to 1K, 2.2K, and 2.7K. And then we'll join them up again and go back to ground. So the way a current works is we have a current I, we measure I, and this will be the total I that comes in. And that's what we call I naught, if you look on the handout. And then what we're going to have then is I1, I2, and I3. And the way it's going to work is this current, which is number of electrons passing per second, will pass through and then split up into each one of these three. So what we're going to do here, we're not going to predict it in this case. What we're going to do is just measure what we get, and it should be that I naught equals I1 plus I2 plus I3. So we need to measure I naught, and the way to do that, and I'll show that in the next part, is when we actually do it, is I will set it up, is for doing current, I'll show we have to actually take it out to do it. All right, for the last part here, we're going to be measuring current, and we're going to look at a circuit where we have a 1K. Again, I explained it, and we're going to measure first the resistance in the 1K, the current in the 1K, and the way we do that is we have to pull out a wire, run it through the ammeter, and then back to the other ones. So we'll do this one at a time. And we're going to see is I naught will be the first one. So all the current goes through here and then gets divided into each of these. And we'll see if the total adds up to be the same. So I've got it set up for here. And all right, there is the current, 6.01 milliamps. So 6.01 would be the current for that. Okay, that's I naught. All right. Or 6.02. All right, now what I'm going to do is take this, put this down, hook up, put this back. Now what I'm going to do is then measure the current through each one of these. And what I'm going to do is hook the black side up to ground, and then pull one out each time, and measure the current for each one. So this is this is I1, the 1 kilo ohm. All right, there you see current 3.30 milliamps. So 3.30. All right, so we go through just one. We'll put that back. And we'll do the next one and get to it. Okay, so now we'll do the next one. That's the 2.2, and the current is 1.52 milliamps. So that's I2. All right, then we'll leave that up. Then we're going to do the last one. And I'll pull the last one out and measure current through that one, and that's 1.22. 1.22. All right, so now you're going to do is that's the currents through I1, I2, I3. You then take the total of those, see what is the total, and we're going to compare that to the result we got here. All right? So that is resistance, and we have circuit in parallel. Electrocardiogram. It's kind of an application to biology majors in the class. And what we're going to do is look at the last handout. What we have is a sample we actually took of an EKG from a person. In this case, we're not going to have you actually do it yourself. But we have on the left graph is we have pulses. You can see that from the handout. Just get that for a time of 6 seconds. And from there, determine what the person's heart rate, the beats per minute is for the first part. Then we expand one of these into this, and using either the book, which is good about that, as far as the different parts of a heartbeat, you know, the P, Q, R, S, T, and such. And so what you're going to do is using this, and this is voltage, millivolts, and time, is then determine the voltage using this graph for the P part, the Q, the R, S, T, and X. So identifying which each one of those are, you need to do that first. Again, the book does it very well as far as identifying each one. That compares extremely well to the actual data we have. All right, so we're not going to actually, so that's the last part of the lab. We're not actually going to take a person's part. So, and we're not going to worry about the last question there. So that is lab 4 on voltage and parts related to chapter 17, 18. It's mostly 18.